Welcome to the Horses Equine Innovators podcast, sponsored by Zoetis Animal Health. I'm your host, Michelle Anderson, Digital Managing Editor of The Horse. Each day, researchers at universities and other institutions around the world are investigating new ways to care for and understand our horses. In this podcast series, we're talking to those innovators to learn more about their work. Today, we're specifically talking about the science behind racetrack surfaces. Our guest is Dr. Mick Peterson, who's a professor of biosystems and agricultural engineering at the University of Kentucky. He also serves as the director of UK's Racetrack Safety Program. His specialty is animal biomechanics engineering, specifically racehorses and racetrack surfaces. Thanks for taking the time to talk to us, Dr. Peterson.
Thanks for having me.
Before we dive into our conversation, we have a message from our sponsor, Zoetis. Small strongyles are the greatest parasite concern for adult horses today. Give your best friend the parasite protection he deserves by using Quest Gel in the spring and Quest Gel Plus in the fall. Both products from Zoetis include moxidectin, the active ingredient that equine experts recommend to combat harmful parasites. Visit questhorse.com to learn more. Do not use Quest Gel or Quest Gel Plus in foals less than 6 months of age, or in sick, debilitated, or underweight horses. Do not use in other animal species, as severe adverse reactions, including fatalities in dogs, may result. So with our housekeeping out of the way, we'll go ahead and turn back to racetrack surfaces, Dr. Peterson. So you have a very, very specific specialty. Were you an engineer who happened to fall into racetrack surfaces, or were you a horse person who became an engineer so you could study racetrack surfaces?
It's funny, I didn't have a horse background at all, and I think there's people that still argue now that I've got some real blind spots on my horse knowledge as it is. But I was originally involved in this. We were looking at exercise-induced arthrosis in the horse when I was an assistant professor at Colorado State about 20 years ago. I've learned a lot about horses and a lot about horse racing since then, but I came in very much through a back door.
So how did you make that connection into the horse world as an engineer?
Well, I was actually working, some of the listeners may even know Dr. Wayne McElraith. He's a pretty big dog in the horse world, as you might say. I was working with Wayne McElraith and some grad students, and actually one of his PhD students is Chris Kowchek, who's now a chaired professor at Colorado State. It was his dissertation. And they were looking at exercise-induced arthrosis and using horses on treadmills. And my contribution to that project was I was looking at the imaging. We were looking at slices of the bones and looking at the bone remodeling and looking at areas where fractures would be likely to initiate from overuse or over-exercise. But you can imagine the whole dynamics of running on a treadmill is very different. It's a very hard surface. So what got me originally involved in racetracks was we were looking at this problem, and the next step was to put them on more physiologically representative surface. And they had this little training track at Colorado State. And so if we were going to be able to reproduce the study, I said, well, why don't we use whatever test characterizations is used in racing to characterize the surfaces, just so we can represent the surface. And I was there with a group of veterinarians who said, well, I don't think they do anything. And I did a little looking into it, and I realized that there was no standard characterization for racetrack surfaces. So at the time, we ended up writing two proposals, one about exercise-induced arthrosis and one about measuring the racetrack surface so that we could train the horses on a surface that we could reproduce.
So for our listeners, especially those who aren't really invested in the racehorse world, you're there in Lexington, and in Lexington, it's all about the horse racing. But for those of us who aren't in that culture, why is researching and studying these racetrack surfaces so important for our horses?
Well, one of the big things, and there's been a lot of pressure on horse racing because of the catastrophic injuries, But as soon as I mention the catastrophic injuries and the risk to the horse, I immediately have to mention there's a rider on the back of every one of those horses as well. And while we've made some progress, there's so many factors that go into the safety of the horse and rider. Racetrack surfaces is one of them, but like pre-race exams that are done by the regulatory vets, racetrack surfaces affect every horse that's out there on the surface. So it's a good starting point, and it's something that we can affect. It's what one professor I had in graduate called a solvable unsolved problem is the way I approach it. There's a lot of difficult problems in health in general, and this is one of those where I feel like we can make progress.
So catastrophic injuries come to mind when we're talking about racetrack surfaces, but is there any other important reason to be looking at track surfaces? Is there anything that has to do with the fitness and the performance of the animals as well?
Well, one of the things that I've consistently thought to be a huge challenge for racing is understanding how the trainers can make training decisions if they don't have a consistent surface. So the real challenge is if you're training a horse and you're looking at fitness and you're doing timed works, if the track changes significantly, it's very difficult to tell whether the horse is fit and whether they're maintaining their fitness and making all those decisions I know nothing about. I mean, certainly I'd starve to death if I was a horse trainer. But I just feel like providing as much information as possible to the trainer and keeping it as consistent as possible allows them to have a consistent basis for their decision making.
So you mentioned Dr. McElraith, do you work with veterinarians on a regular basis in this research area? And then are you also working with those trainers to help understand their needs?
Yeah, I've worked a lot with veterinarians. I work with certainly Mary Scoulet, the equine medical director who's now at Racing Medication and Testing Consortium, and Wayne McElraith are the two people who got me involved in this on the veterinary side. Scott Palmer is the equine medical director in New York, and Rick Arthur in California are also been very important to the whole process. So I work probably less with the practicing vets and more with the equine medical directors. And now as we're seeing the big companies that own racetracks, Churchill Downs, Stronach Group, also employ separate equine medical directors, it's getting I'm ending up with more and more veterinarians I interact with.
Yeah. So in your research, can you explain for our listeners how the horses interact with the surface and why that's important?
Well, the real challenge, and in this extent, and we've done more and more recently with sport horses, but racing, we know what the horse is doing. The horse is galloping, the horse is turning left in North America. You know, we've got a pretty well-defined problem. But if you think the horse is going 35 miles an hour, but the foot is stopped a portion of the time, that hoof has to fly through the air at 70 miles an hour in order to keep up with the horse, as the horse is moving at a constant speed because the hoof is stopped part of the time. So the loading on the hoof and the dynamics of the hoof interacting with the surface are just absolutely amazing from an engineering standpoint. If you think the acceleration due to gravity is referred to as a G, it's a measurement, it's 9.8 meters per second squared, and that's how an object accelerates if you drop it. We regularly measure 150 or 200 G decelerations when the hoof hits the ground. Fighter planes, you're talking 8 or 9 Gs that the pilot would experience. So the interaction of this hoof with the ground is an incredibly dynamic event, much closer to ballistics than it is to something that you do statically, like standing around or the speed one of us would normally walk.
Oh. So you mentioned North America, and I think that most of our racing, and you can correct me if I'm wrong, it's on dirt here. and not turf. Are you studying turf surfaces as well as dirt?
That's a really interesting point. Yes, we do work. We work with synthetic dirt and turf, but what's really important about the turf is a decade ago, only about 10% of the starts in North America were on turf. Last year, there were over 20% of the starts were on turf. There is a huge demand in North America for more turf racing, and there's actually there's a PhD student who's working with me who started his PhD working exclusively with turf for thoroughbred racing. Interesting. There's been a PhD in synthetic tracks who focused primarily on the wax and the degradation of the wax and the characterization of the wax that's used in the synthetic surfaces. There was a second PhD who worked with dirt, and now this is the third PhD in racetrack surfaces, and it will be focused on turf. So we're seeing a huge growth in turf. Woodbine took the harness track on the inside of their turf track and converted it to a second turf track. At Aqueduct, there used to be 2 dirt tracks. Now there's 2 turf tracks. So it's an interesting time from the standpoint of turf.
Well, and so you're talking about the dirt and the synthetic surfaces. There's some options here, but I'm thinking, like, I'm in Oregon and I put in a riding arena on our property, and I didn't realize it until I went to put in an arena that I was limited in my footing options by the natural materials and the distance they had to be trucked to Central Oregon. So where do the tracks get their footing? Are they local, and are they all different all over the country?
No, they aren't local. I think probably the most extreme case was the synthetic track that was put in at Hollywood Park, which is now no longer with us. That synthetic track actually was mixed in England and brought to the U.S. On ships to go to Hollywood Park. One of the Florida tracks actually was done with Maryland sand, and it's interesting that you'd mentioned that. One of our biggest goals has been to develop methods for testing the sand so that if there is an option for a local sand, that we can utilize that local sand. Because what's traditionally been done in the sport horse world, there's a couple mines in Europe that are used almost exclusively for all the surfaces in Europe, and our goal is to widen those options so that we can identify local sands that meet specifications. But that's involved figuring out what the people who have the touch and feel are identifying. So oftentimes we're taking people's good judgment and experience and trying to quantify it so that partly if something happens to that person who's really good at it, we've got some backup.
Which is why you want to put the science behind it, right?
It is. And then, of course, if we understand the decisions they're making, we also have the opportunity then to say, well, is this the next step? And begin a dialogue of how we can improve further.
I have a friend here in Central Oregon who put in an arena, and she trucked in sand from the Oregon coast. We have Oregon coast, if you've never been there, is really beautiful sand beaches. And here in Central Oregon, we have kind of this lava sand that's not fantastic for anything. But anyway, she brought in the sand from the beach, and you go in our arena and you just want to like get out a chaise lounger and a margarita and sit in this beautiful sand. So she has quite the investment in her arena. So so you are talking about monitoring tracks all over the country. You're there in Lexington, but are you the only person in the country doing this work?
We are. We travel to the track. So we've really got a 3-step process that we work with the racetracks on, and we call it the maintenance quality system, which that's about as much marketing as you get out of a middle-aged engineer. But At least I try to use the same name for it over and over. But the maintenance quality system is 3 steps. One is when we first start working with a racetrack, we document the equipment they're using, and we set targets based on their current design, assuming they're happy with what their surface is. The second stage is before each race meet, we test standard samples, and we do the laboratory testing of the material, and then we bring equipment in from all over the country to test the track, to use the biomechanical surface tester, which replicates the front leg of a thoroughbred at a gallop. So it's a big piece of equipment because it's putting 2,500 pounds of load at 30 miles an hour onto the surface. And then we use ground penetrating radar to inspect the base to make sure everything's as consistent as possible. And we also go through and inspect the equipment, look through to make sure we aren't seeing any issues with maintenance equipment. The third stage, which is probably the hardest part, is the daily monitoring, because what we're doing before the race meet is we say, if this track is properly maintained, it will match up with the standards that we set from other tracks. Then on a daily basis, we have to say, have the racetrack superintendent and their crew done what they needed to do in order to adapt to the weather and the usage of the track by horses. That third stage, well, the analogy I make, and I apologize, this is an engineering analogy, not an equine analogy, but it's really very much like you do with an airplane. The first stage is really the FAA certification of the track. It's really, if the FAA works with Boeing, they say, yep, you're ready to fly. The second stage is very much like you're sitting there waiting on the runway to take off, and you have to have all your paperwork done, and everybody has to inspect everything, and all the right settings have to be on the plane before you can take off. The third stage, which is really what we're working on more than anything now, is the black box. That's the monitoring every day during the races, so we know everything that's happening to the track. One of the things we've got is a weather station in each of the tracks. It logs the weather, temperature, moisture every 15 minutes. And every time a piece of equipment goes out onto the racetrack, they log the settings and the condition of that. And what we're working on right now is automating more of that.
So you're monitoring these tracks. What if the measurements come back and it's suboptimal? It's not okay to race on. Does that happen, or is that a concern, or is there a protocol in place to prevent that from happening?
Absolutely, and this is one of the reasons why that pre-race inspection is so critical. And I should mention, keeping up with that was a real problem until quite recently. And a little over a year ago, the Jockey Club provided significant funding for us to duplicate the equipment so we can pre-position it and follow up with the different tracks that are starting. Sometimes you have top meets. For example, Saratoga and Del Mar might be starting within a few days of each other. We had one set of equipment that we were driving back and forth from New York to Del Mar. And the critical thing that you've identified is we have to give them time to fix anything before the horses go out on the track. And if we're not seeing anything if we see anything that is not right, we just wait. We fix it, and it's not a, look, you're wrong, we'll see you next year. It's, we stay there, we work with the track superintendent to fix it. So the most common example of that is grading. The dirt moves downhill, the turns are banked, the inside of the turn can get deep. You pay attention to it, but if you have difficult rain, it can segregate the material, so you can have the fine material down along the rail. If we find anything like that, we just work with them and we get it fixed before the race meet.
So how long before a meet are you looking at the track and working the track so that it's ready for the start of that track's meet?
that's probably been one of our biggest successes, is coming up with sort of what we have to do before the race meet. This is especially true with the seasonal meets, the Saratoga, the Oaklawn, the Del Mar, the seasonal meets, where the track is closed, or at Del Mar it's used for the San Diego Fair prior to the race meet. So what we do is we get all of our basic tests done. So if you're going to have to add material, we get that taken care of at least a month or 6 weeks ahead of time, because you'll have to bring in sand and put it down and then mix it. The other important thing is you set up what they call a hard pan, and that's basically taking the top layer that's harrowed, that's 3 or 4 inches deep, that top layer that's harrowed, and you're setting up a false bottom underneath that because of the harrow teeth. That requires a lot of times going around in a circle with a harrow. And so what we've successfully shown is that if we control the moisture content carefully while we do that at a racetrack like Del Mar, where you don't necessarily have a long time between the fair and the race meet, we basically run race days without any horses to get everything set up. It serves 2 purposes. One is it sets up the hard pan and gets a consistent cushion. The other thing is, when you've got a seasonal meet, you have a seasonal crew, it also gets the choreography all sorted out. Nobody's going to turn left instead of right coming out of the tractor yard on opening day. Everything just works smoothly when you get started. So Oaklawn does that, Saratoga does it, Del Mar is super challenging just because of the fair, and so they've now systematically done this same process. And the nice thing is everybody learns from everybody else, and we basically end up with best practices.
So, as an engineer and a researcher, is there something that really stands out to you that you have found in your work, something that's that you're either most proud of or you found most interesting as you researched these track surfaces?
Well, it seems like we keep having little breakthroughs, and none of them are particularly amazing. And it's one of those challenging fields because every detail has to be correct. So, for example, with the synthetic surfaces that have the wax in it, it's been really interesting learning how the waxes degrade over time. They get sticky, and I didn't understand that. I thought maybe the oils were evaporating. We've now essentially shown that what happens is the long wax chains scissor, and so you get a little active groups on the end there, and those active groups get sticky, and so you get a sticky surface. That's the sort of thing where it's like, there's probably a solution to this to keep it from getting sticky. The turf and the dirt, the overwhelming control challenge on that is moisture. I mean, it's water is what we talk about. And so one of the things that I'm most excited about now is some of the work we're doing to get real-time moisture content off of the tracks. It's hard enough to keep the moisture consistent at a track like Saratoga, but it's just overwhelming when you look at it at Santa Anita, because it'll rain in the winter in the morning, and by the 3rd race, if you have the Santa Ana winds coming out of the mountains, you're eyeing the water truck halfway through the race card. So that's an incredibly challenging situation for them. And so as we get better at understanding these moisture measurements, and if we can get them in real time, it'll be a huge help, and I think it'll be a way to keep the tracks more consistent.
So we've mentioned catastrophic breakdowns, so horse safety, and also rider and jockey safety. Do you feel like this work is helping improve safety for the horses and the humans that are on the tracks that you're monitoring?
Absolutely, and there's several things that we've found over the years that there's some things that we've found that would never happen that regularly would happen 10 or 15 years ago, and making sure we can keep the horses upright. The challenge though is, and if you'll forgive me, I'm going to use another analogy from airplanes. It's like the 737 MAX. You talk about those two terrible crashes with the 737 MAX planes, and it took a whole sequence of failures to have that happen. They had the optional gauge that wasn't there. They had the second sensor. The pilots hadn't been trained. It was like you look at it. It's like every one of these things had to go wrong in order to have the loss of life in both those cases. We're kind of in the same situation here. So the challenge for us is to keep our eye on the ball and work on all of the issues. When Boeing announced that they were going to fix the 737 MAX, they didn't say, well, I'm just going to go retrain the pilots. No, they're going to retrain the pilots. They're going to put in the other sensor and give an indicator when the second sensor goes out. Then they're going to, put logic in so that it won't correct the plane more than twice. We've got the same thing with the racetracks. We need to get the water better. We need to keep the moisture more consistent. But, we also need to make sure the pre-race exams are optimal and that the trainers, as you mentioned, have the information they need in order to make decisions. Because ultimately, they're the ones who know the horses the best and will make the best decisions. So you've got to kind of do all of the above, which is a challenge from a political standpoint and a financial standpoint, but it matters.
So you mentioned arenas earlier and work and footing in sport horse arenas. Does the research that you're doing also apply to performance in sport horse arenas where we're competing in jumping or barrel racing or reining, dressage? Can these principles be applied there as well?
Yeah, we've worked pretty extensively with the FEI. I haven't been the lead on that. Lars Ropstroff and Sarah Jane Hobbs. Sarah Jane Hobbs is at University of Central Lancashire in England, and Lars Ropstroff is at Swedish University of Agriculture. And the three of us have worked together now. I don't know, it's probably been 15 years. So I've been doing this almost 25 years, and we've probably been 15 of that. We've been talking or working together. And there are a series of tests that have been an adaptation of what I've done that are now used at the 4- and 5-star events with the FEI. The first time was during the London Olympics. Sarah Jane Hobbs had one of her machines, the OBST, the biomechanical surface tester, that had been modified for show jumping, and Lars had his, and so there are actually two of the machines at the London Olympics. Since then, the World Equestrian Games at Cannes and Tryon, as well as the Rio Olympics, and we've done the testing for Tokyo. I hope the pudding gets to get used at some point, but
yeah.
So Tokyo went through the entire process sequentially, just exactly like we envisioned, where we did all the testing of the material in the Racing Surfaces Testing Laboratory. Lars did the test event with the OBST, and the Japanese have just done an extraordinarily good job of complying with all the steps. You know what I mean? It's the local organizing committee has just been a pleasure to work with.
Yeah. Well, maybe next year we'll see
Exactly.
if that beautiful footing. As a dressage rider, like, to have beautiful footing go to waste just breaks my heart.
I'm sure they'll find somebody who'll be using it. They've got a lot of money into it at this point.
So you've been doing this work for 25 years. You started out as not a horse person. You were an engineer who ended up connecting with veterinary researchers. Do you now, as someone who lives in the heart of horse country and is looking at racetracks every day, do you consider yourself a horse person now?
Well, to give you an idea, before the interview, I did have to turn off TVG that was running in the corner while I was working. So yeah, no, I mean, as far as going down the rabbit hole, I think I've solidly gone underground. You know, I mean, and and moving from Maine to Lexington was just fascinating because you know I went into the UPS store the other day and the guy who owns the UPS store wanted to talk about when he'd seen Big Brown at Belmont. And so you know it really is, and what it's really forced me to up my game because I a lot of the horses that people stand there, you know, the guy at the UPS store is talking about was before I was deeply involved in this. So I learned my horse history too. You know?
Yeah. Well, as someone who lives in Oregon but works there in Lexington, so when we're not in the middle of a pandemic, I spend quite a bit of time there at the office in Lexington, and it doesn't matter where you go to breakfast, the group at the booth next to you will be talking about their morning works and their breeding plans for the day. So it's definitely a different world. But I'm glad, as a horse person, I'm glad we hooked you because we can use all the horse people we can get. So I want to thank you for taking the time to answer our questions and being a part of the podcast, Dr. Peterson. It was a pleasure to talk to you about this.
Well, it was fun talking, and as I'm very passionate about this, and the support from the industry and the growth in this industry is it's quite exciting where we're at, even in these challenging times.
For our listeners, if you haven't already, you can subscribe to our Equine Innovators podcast and Ask the Horse Live wherever you enjoy your favorite podcasts, or you can sign up at thehorse.com to receive our emails and announcements. From all of us at The Horse, thanks for listening, and we hope you can join us next time.